Welcome back to Advanced Skills Learning. Today we're tackling a question that comes up in almost every Gen AI architecture discussion right now. When does Agentic RAG actually make sense? And when is it just unnecessary complexity that quietly makes your system worse? Agentic RAG is one of the most overused ideas in Gen AI today. As soon as teams hit a limitation with classic RAG, the instinct is to add agents, planners, tool callers, reflection loops. And it looks powerful, but here's the uncomfortable truth. Adding agents does not automatically make your system smarter. In many real systems, it makes them slower, harder to debug, and less predictable. So while agentic systems look impressive in demos, in production they often introduce new problems: higher latency, unpredictable behavior, and much harder evaluation. Let's start by grounding ourselves. Classic RAG works extremely well for a multitude of problems because it's simple. A user asks a question, you retrieve relevant documents, pass that context to the model, and generate an answer. The execution path is fixed. Latency is predictable. Failures are easy to reason about. And for a surprisingly large number of enterprise use cases, FAQs, policy search, internal documentation, knowledge base lookup, classic RAG is not a limitation. It's the optimal solution. The trouble begins when teams try to stretch classic RAG beyond what it's designed for. You start seeing questions that are not single retrieval problems. Questions that require multiple steps, interpretation, or conditional logic. For example, troubleshooting issues that depend on environment state, compliance checks that vary by jurisdiction, or operational questions that require combining data from different systems. This is where people reach for agents, sometimes too early. In these cases, classic RAG doesn't fail loudly, it fails quietly. The model answers something, but it's shallow, incomplete, or confidently wrong. And that's when people say, we need agents. But Agentic RAG is not just RAG plus more prompts. At its core, Agentic RAG means the system can make decisions about what to do next at runtime. It can break a question into parts and make decisions like, do I need more information? Which retriever should I use? Should I call a tool? Have I answered the question well enough to stop? Retrieval becomes conditional based on the decision, not a fixed step. Now, it's important to say where Agentic RAG is overkill. If your queries are low ambiguity, if the content is static, if the answer is usually found in one place, agents add no value. You're paying extra cost and complexity just to arrive at the same answer more slowly. Here agents are a tax you don't need to pay. You'll increase latency, cost, and failure modes without gaining accuracy. Agentic RAG starts to make sense when the task itself requires orchestration. Multi-hop reasoning, where one answer depends on another. When a single query hides multiple sub-questions. Tool-driven workflows, where some information lives in APIs or databases instead of embeddings. Or conditional logic, where the next step depends on what you just learned. When the system needs to reason about what to do next, not just what to retrieve. This is common in diagnostic workflows, decision support systems, and enterprise assistants that span multiple domains. Quick check, 2 seconds. Which use case actually benefits from Agentic RAG? A. An FAQ chatbot. B. A multi-step troubleshooting assistant. C. Static product search. Keep your guess. The answer is B. Multi-step troubleshooting. One powerful agentic pattern is query decomposition. Instead of issuing one broad retrieval or asking one giant question, the agent breaks the question into smaller, focused subqueries. Each subquery retrieves its own context, and the agent then synthesizes a final answer. This dramatically reduces hallucinations and improves accuracy for complex queries because each step is grounded independently. Another important pattern is tool-guided retrieval. Sometimes vector search is the wrong tool. Not all knowledge belongs in embeddings. And sometimes the most reliable answer comes from an API call, a database query, or a rules engine. An agent can decide when vector search is appropriate, and when it isn't. This is especially critical in enterprise systems where real-time data matters or where knowledge isn't just documents. A third pattern is iterative refinement. The agent evaluates the retrieved context and asks a simple internal question: is this enough? If the answer is no due to low confidence or missing information, it reformulates the query, switches retrieval strategies, or pulls in another tool. If the answer is yes, it stops. This stopping decision is what separates useful agents from infinite loops. Quick check, 2 seconds. Which statement is true? A. More agents always improve accuracy. B. Agents help when decisions are required. C. Agents replace evaluation. Keep your guess. The answer is B. Agents help when decisions are required. Here's the key takeaway. Agentic RAG is not a default upgrade. Start simple, earn complexity. It's a targeted solution for coordination problems, not retrieval problems. Start with classic RAG, measure its failures. If classic RAG can solve your problem, don't outsmart yourself. Only introduce agents when your system genuinely needs runtime decisions, multi-step reasoning, or tool orchestration. If you can't clearly explain why an agent is needed, that's usually a sign it isn't. Agents are powerful, but only when they're solving a real coordination problem. Thanks for watching. If this video helped, like the video and subscribe to Advanced Skills Learning for more Gen AI explainers, practical architectures, and quick quizzes to test your understanding.